Morning, everyone. So my name is David Mytton, and I'm the founder of Server Density. We've been going about 6 years now, and we do systems monitoring and availability monitoring. So we monitor the 999 systems in the UK. We work with Boeing in the US to monitor some of their systems, but most of our customers are actually around our size, small startups and small businesses. So I'm going to talk to you a bit about the human side of things, which will get into some of how we do some of the things that Charity just talked about, particularly when it comes to making sure people have good quality of life when they're on call, and how you deal with incidents. Now, the first thing I want to introduce this is about the cost of uptime. And to illustrate this, I want to look at the three biggest infrastructure providers in the world: Google, Amazon, and Microsoft, and in particular, their public cloud infrastructure. Now, if we take a look at Google's financial information, you can see that in Q1 of this year, they spent almost $3 billion on capital expenditure. And most of this is going to go towards data centers and infrastructure. And just a couple of days ago, they had a multi-hour outage on App Engine, which also affected their developer console. In the last quarter just gone, Amazon spent $1.2 billion on capital expenditure. Now with Amazon, it's a little harder because they obviously have warehouses and another business, but there is a significant spend. They have over 28 data centers worldwide, and they're growing that. And I'm sure many of you had a fun weekend on Sunday when they had a multi-hour outage as well. And then Microsoft are also spending billions of dollars per quarter on their infrastructure. And if you take a look at their status page, you can see that they have regular outages of various services. Now, the point of this is not to call out these infrastructure providers. If you have problems, then it's really to do with your architecture in most cases. But the key point is that how much are you spending, and what does that mean for your uptime? And essentially, 100% uptime of underlying services is impossible. Regardless of how many billions of dollars the best companies in the world spend on these, you're not going to be able to get anywhere near that. And so that means you have to expect and prepare for these problems. And that's what this talk is going to be about. It's going to be talking a little bit about the preparation, and then when it does happen, and it will happen multiple times, how you respond to that in the actual real time of the incident. And then once the incident is resolved, what you do afterwards to wrap it up, make sure it doesn't happen again, and to inform your customers. So the first part of this is the preparation. And this isn't necessarily the technical details of how you deal with failover in your application. It's the human side of the preparation. And the first part of this is defining your on-call team. Well, Server Density is about 20 people now. When I started, it was myself and my co-founder. And so we've grown over the years and built up a small team around the product. And the way that we've distributed the responsibility for on-call is by having 2 people on call at any one time. And we split this up into what we call the primary and the secondary role. Now, the primary will be the first person who gets the notification that there's a problem, there's an incident going on. And it's their responsibility to be able to respond to that alert within a couple of minutes. And then we have the secondary, who is also on call, but is there as a backup. And it's their job to be available, but available within an SLA of about 30 minutes to an hour. And we split this up across the whole team. So we have some dedicated ops engineers, but we have a larger engineering team. And we rotate this responsibility through all of them. So all of the engineers will take a period of being the primary, and all of the ops engineers will also be primary. But we split it up so that the secondary, the backup, is only part of the ops team. And the reason for this is that we expect our engineers who are on the primary to be able to solve most problems. And if they can't, it's probably because they don't have some expertise in a particular system, or they need some real help. And that's where our operations team will come in. And so they're there as the backup. But we fully expect our engineers to be able to solve most issues. And I'll talk about how we do that and how we train our team for that. And we do this on a rotation. So each engineer will have a week on call, and this starts on a Tuesday, around midday, and we have a formal handoff procedure. So the person who was on call previously will chat for maybe 5 or 10 minutes with the person they're handing it over to. And we just run through a small checklist so that the person who is coming on call is aware of any known issues, things that might come up. Maybe we've got a patch in production that is temporary, but might be expected to cause some problems. And we just run through the known issues in the infrastructure. And we also review any incidents that might have happened, and if there's a fix pending, how to resolve those before the fix is released. And everyone in the team will spend this week on call, includes over the weekend, and people tend to have six to 7 weeks off, and then 1 week on call. And one of the things that we do when we plan our on-call calendar, we use PagerDuty to handle this, is that we look at holidays, we look at people's school runs, we look at local holidays because we have team members in the UK but also in Portugal and Spain. We also look at whether they might have some commitments up in advance that we need to work around, and if there's a big release that might be coming up that they are responsible for, then we might allow them to skip a week so that their on-call duties don't affect the general roadmap of the product. Reachability is really important here because we have that SLA of a couple of minutes response for the primary, and then within an hour or so for the secondary. And this is things like, are they going to be traveling to the office or back? And maybe they're on the tube and they don't have phone reception. Or maybe they go to the gym in the morning, and so we need some cover there. And this is because the on-call responsibility is important, but it's not going to rule their lives. It doesn't mean that they can't get their exercise in. It doesn't mean that they can't drive to school and back with their kids. We want to make sure that this fits in. And it may just be 20 or 30 minutes that they need someone else to take their duties, but we make sure that is all planned into the schedule. Now, there will be those incidents that happen in the middle of the night that wake people up. And when we have these out-of-hours incidents, we implement a rule where for the next 24 hours after that, they're off call. Even if they're scheduled in, we need to give them time to recover. In many cases, people will still do some work the following day, depending on what the issue was and how long it took them, what disruption there was. Maybe there was nothing, which is great. But we want to make sure that people have that time to recover. It's the same when you do exercise and you go to the gym. You want to have that recovery period after a period of activity. And this just reduces fatigue and stress and make sure that people are fully rested. Well, documentation is also important for the preparation, and people really hate writing documentation, and so we consider our config management tools to be as much of the documentation as possible. So things like Puppet or Chef, they describe your infrastructure, and many things you don't need to explicitly write out just because they're already described by your config management tools. But of course, there are going to be things that you can't just rely on people knowing the code or reading the code at important times. And so having good documentation is really key to preparation. Well, one of the key facts, or one of the key characteristics of good documentation is that it is searchable. We have documents for all the known alert types, all the known issues, and we are very careful to put in the titles of those documents and within the document itself keywords that you might need to search on. So for example, when you get paged with a particular error string, you then want to put that error string into the search, and it will immediately bring up the document which tells you how to fix that problem. You don't want to be scrambling around to try and figure out what a particular alert means or how to actually solve it. It's also important that your documentation is completely independent from your primary infrastructure. So it's no good having a self-hosted Confluence wiki that is in AWS in the same zone that your primary infrastructure is in, because when that goes down, you have no documentation. So the way that we do this, we're deployed on SoftLayer in a couple of their data centers, and so we use Google Docs. The search can be a bit of a pain in that it doesn't work for searching inside documents, but it is very, very good on matching the titles of things. And I wrote a blog post about this, and some people commented with their alternative suggestions. People use GitHub if you want to locate your documentation close to your code. GitHub search is actually very good. Or a Confluence wiki, something, whatever really fits in with you. We use Google Apps, and this fits in nicely with our team. And so we have a particular folder that is shared. Everyone in the team can see this and can make documents, make changes, comment on them, and it is searchable. Now, also part of the preparation is having key information available at all times and up to date. And one of these is team contacts. People are always changing the way that they prefer to get communicated with new mobile apps and might change their phone number. We have a spreadsheet, simple spreadsheet really, which works for us up to a certain number of people, and then perhaps when your team gets larger, Active Directory style applications make sense. But we have a simple spreadsheet which just lists everyone in the team, their mobile phone numbers, and also the home phone number as well, just in case we can't reach them through the mobile. We also have key vendor contacts. We have support contracts with a number of different application providers that we use. And when there's an incident, you want to make sure that your team can get access to the support that you've paid probably a lot of money for. And so having the key contacts, both your account manager, but also the support process, because it can differ from company to company. Sometimes you submit a ticket first and then you call them. Sometimes you call them and then they give you a ticket number. It's best to have that procedure just jotted down so that when you need to contact them in a quick emergency, you know the right step to submit a ticket so that you can actually get the SLA response time that you're paying for. So having these in an easy searchable format is really important so that the team can access them. And along the same lines is making sure that the right people have access to the right systems, making sure that everyone has their own user account if possible, so you can comply with various security requirements. Ideally, you don't have just one login that everyone shares, but in some cases that may be the case. And so making sure that everyone has access to these details so you can log into the ticket system or log into the phone support system. This is kind of the fun side of things because it allows you to think about apocalyptic scenarios that probably won't ever happen, but you never know, they might do. So communication is really important here. And we use HipChat internally. Slack is the new cool thing. Whatever it is that you're using, try and understand where that is hosted. Because if you're on AWS and HipChat is on AWS, which they are, and then when AWS has an outage, it may affect your primary communication tool for your team. And so the key here is to have a backup option. So if you can't log into HipChat or whatever system it is you're using, you just need to have a secondary method that everyone knows where to go. It could be Skype, it could be IRC, something simple that doesn't take much time to just have available just as a backup option. And also considering people's internet access. Now this only really happens in extreme situations, but for example, Hurricane Sandy in the US caused major issues in a specific geographical area. And if your entire team is in that area, it may mean that their access to the internet is affected. Flooded data centers, people overloading the network, that kind of thing. At Civ Identity, we're lucky because our team is distributed around the UK and Europe. And so any issue that affects everyone is probably going to be a problem for all of us and isn't going to be something we can solve. But to consider different ISPs that you're using for your on-call team, and in particular, the primary and the secondary, and just making sure that they're not on the same internet provider, they're not on the same mobile network, so that you can be sure that you get the alerts. Now, in many cases, this may be overkill. But for us running a monitoring company, uptime is important, and so we have to take these kind of precautions. And also access to support. I remember it was probably 10 years ago now, a truck drove into Rackspace's data center in the US, and every single customer phoned them, which meant their phone support was down. This just means you can't access support. If your servers have been driven into by a truck, there's probably not much their support team can do. But just being able to contact a support team to understand what the situation is when something is outside of your control This is really talking to your critical vendors to understand their disaster recovery plans, making sure that they have considered these things. And the final point on the preparation then is about war games. And this is something that we've fairly recently started doing. We had an incident earlier in the year which took us about 40 minutes to resolve. When we did the post-mortem, we realized about 20 minutes of that was the team trying to figure out how to actually solve the problem. And so since then, we've instituted war games where we have the whole team in our office and we will simulate an incident, and everybody will run through the actual response plan, including executing commands. Not actually in production, obviously, in a staging environment, but we then review what people are doing. And this is the first principle that we take from the airline industry, and there's a couple of others I will go into, of just simulating incidents. So pilots are obviously very well trained for all the possible failure scenarios that are likely to happen or unlikely to happen even during a flight. And it's the same with your operations team and the engineering team. We go through all of the alerts that we've got configured, we figure out what might cause them, and we throw in a few interesting cases just to try and throw them off a little bit, but actually test their incident response processes. And we've just started doing this, so I'm planning to write this up in a bit more detail once we've run through a couple of iterations of it, because there's obviously improvements that come out of that. But if you Google war games, then other companies are already doing this. Google does this on a massive scale. They for example, they shut down their entire Mountain View campus and see what happens to the other offices. But for us, that's probably a bit overkill. But we still do simulations of outages. Okay, so responding. When you get that alert, it wakes you up, we go through a very particular process. The first thing is that we load up our incident response checklist. And this is essentially the next few steps are what's in that checklist. So the first step is to log into our ops war room. And this is the second principle that we take from the airline industry, which is the sterile cockpit rule. This room is completely silent, except for crucial communication. And during the critical parts of flight, so takeoff, landing, dealing with incidents, there's no non-essential communication in the cockpit between pilots. They don't talk about the weather, unless that's the key issue, and they don't talk about non-essential things. They just completely utilitarian about how to solve this issue. And this avoids distractions of YouTube videos, commits, things that are completely irrelevant to the incident, and make sure that there is communication happening, but it is only the critical stuff that's going on. And this might be chat, or it could be having an open Skype call, which is mostly silent, but you're just talking through what you're actually doing. After we've logged into our ops war room, we log the incident in Jira. Jira is just a tool we use. It can be anything, as long as you get a unique number for that incident and you can comment on it. That's the only real requirements. And then once we've gone through these 4 steps, that's when we start the investigation. We want to make sure that we've got the right checklist loaded, we want to make sure we're all together, and we've opened up an incident with a unique ID before we actually start doing anything. And we use checklists, and this picture's some, saw in Japan last time I was there, is a nice passive-aggressive anti-smoking picture, which I find quite funny, but is irrelevant to this. Checklists are really important here. And this is for a couple of different reasons. So the first thing is that once you start needing checklists, it's probably because your system is at a level of complexity where there's no one person who really understands everything. It's the same, a third principle from airline industry. They have checklists for every single thing that could possibly go wrong. And this is because you shouldn't really expect your team to know absolutely everything. The idea is that they have a general understanding of the system, but for the actual procedures that they need to do, it's fine to have a checklist that they then work through. So one of the reasons for this is because of stress and fatigue during an incident. You might have perfect understanding of a system when you're fresh in the office on a Monday morning, but if it's Christmas Eve and you may have had a few drinks, probably not if you're on call, but the idea is that you're not in an optimal position. The idea is to have a checklist that will remove any possibility of human error when you're going through the key response steps. And also tiredness. If you're tired from just being woken up, or it's a long-running incident and you have to deal with a number of different failures, having a checklist telling you exactly what to do is really important. Ego is also important to consider here. Consider Denzel Washington's movie with that plane where he flies upside down. He's kind of a maverick pilot, and there may be people on your team who are mavericks and think they know everything. And they may be great engineers, maybe great operations people, but when it comes to responding to an issue, you want to remove anything where they are trying to just wing it, even when you have a defined process. And this goes some way to remove that as a potential problem. And this is one of the checklists that we used just a few weeks ago. This was for upgrading our MongoDB database. We went through a series of checks, and then it tells us essentially what we need to do, including the commands that we actually have to run. And you can see just alongside Pedro, one of our operations engineers, commented what the output was as he was running through that checklist. This is actually really useful because we had to do a rollback after midnight, after discovering a critical undocumented bug in the upgrade. And we were able to do that with minimal customer impact. There was a performance hit, but it meant that we could do a complete database rollback of a fairly major upgrade to our core data store with no customer downtime. And the final principle is having a beginner's mind every time you go through a checklist. And this goes back to the ego part a little bit, but also to dealing with stress and fatigue. Just because you know how to use grep and tail and all these standard commands when you're in the office doesn't necessarily mean you're going to remember them exactly right when you're responding to an issue in the middle of the night. And so the key thing is here that you know really what you're doing, but you can just copy the command and paste it in, and then you respond to the output rather than having that extra, however slight it might be, it's that extra workload of having to remember the correct arguments or what actual command you should be running. And when we're actually responding to an incident, we have a few key principles. And the first of these is that we log absolutely everything. Now, in some cases, this will be on the checklist itself if it's a one-time thing, if we're running through a planned procedure. But if we're responding to an incident where we've created an issue in Jira and we've got that unique key, we will log absolutely everything that happens. And this includes every command that everybody runs. This is a separate comment on the issue. There's a couple of reasons for this. The first is just so that you know what you've done. If something doesn't work, you can just quickly look back and see what you executed and when. If you need to bring other team members into the incident, you want them to be able to quickly scan through the timeline on the ticket. Maybe they've got a different view or a different idea of how to solve it, but it brings them up to speed on what you've tried and what is actually going on. But perhaps most importantly is that you can then review this in the post-mortem at the end, and you can see who did what and when and what the result was. And you can then do a chronological timeline of that. And this is really important for the post-mortem, which we'll come to shortly. Now, server monitoring is a technical product. Our customers are engineers and sysadmins, and so they like to know what is going on when we're dealing with an issue. Just in the same way that if AWS is down or Google Cloud is down, you go to their status page and you understand what they're trying and what's going on. So we try and do frequent public updates. This might just be nothing's changed, we're still restoring a database. But in some cases, you can explain the kind of problems that you're dealing with. It's up to you how much detail you go into. But the idea is that your customers can see publicly that you're still working on something. We update every 30 minutes at a maximum, so that even if nothing has changed, there's an update going out frequently. But the worst thing that you can have as a customer is that the service that you want to use is down, and the last status update from that company was 6 hours ago. And it may be we're restoring a database, but how do you know that they are still working on it? Maybe they've gone to sleep. How long is it going to take? you just need some indication that someone is working on it. You can not relax, but you can sit back knowing that the system, someone is responding to the issue, and it's all in hand, hopefully. And we also have an idea of gathering the whole team, and this is the primary, secondary responsibility. But in major incidents, then we may have to involve other people. And the idea is that you don't try and go at it alone. You don't try and solve the problem when you don't know what is actually going on, or you don't know how to fix it. You shouldn't be alone in the middle of the night trying to solve a major outage when the rest of the team are asleep. And so that means escalate. It's escalate from your primary to your secondary, get them involved. If necessary, escalate it within the rest of the team. And although you may not like it, we do ask people to make sure they are available, reasonably available in the event of this happening. And we've never had to do it, but the team are there behind who is on call just in case there's a major incident. So once the incident is resolved, you've solved the main issue. Hopefully you've logged a few tickets to get engineering support for the root cause. The idea is to go through this in a formal way. And this is the post-mortem. And we try and do this within a couple of days. It allows for the team to recover, particularly if it's a weekend, or if you're relying on a vendor for them to post their post-mortem first. But the idea is to do it within a reasonable period of time. And you want to tell the story, and that's what that ticket is useful for the chronological journey through the incident, is to understand what actually happened and then go into the technical detail. You want to know perhaps when your alerting notified you, when the team responded to that. You want to know the kind of steps that they took and go into the detail to understand what worked and what didn't work. Not all of this has to be public, of course. You want to go into as much detail as possible internally, and you want to get down to that root cause to really understand what caused the outage. Now, in most complex systems, just as with airline crashes, it's not going to be just one thing because you've architected your application correctly. So it's going to be a combination of lots of system failures that all cascaded into that perfect storm to cause the outage. So you want to step through each individual system to understand what failed and why, and then how you actually fix it. And this is the most important part, how it is going to be fixed. Internally, you need to know that this kind of outage is never going to happen again. And this is the air crash investigation style of things. Really going into the detail, understanding what mistakes were made, not blaming people, which is really key, but understanding what factors, the human factors side of it. If you've ever watched air crash investigations, that person who's responsible for interviewing people, and you don't need to go into that level of detail, but it's really understanding was there stress or fatigue involved, and is your checklist not good enough? Was the team fatigued because they'd been dealing with multiple outages, and that's why you need that off-call rule. But the key is that this kind of thing never happens again. And you want to make sure that the engineering team is prioritized correctly. Maybe it needs a fix right away and everyone has to be pulled off. Probably more likely that you can schedule it into the next couple of days, weeks, and the next few sprints to make sure it doesn't come up again. But the idea is that you know exactly what happened and why, and then how you're going to fix it and on what timeline. And then it's up to you what kind of detail you want to go into publicly. We try and go into as much detail as possible when we publish our postmortems, just because our audience likes to understand both from a systems reliability perspective, but also it's kind of interesting to understand your vendors who are running at significant scale. Whenever you read any of the AWS outage postmortems, you learn what happened and what went wrong, but you also learn a little bit about how AWS works behind the scenes, which is really interesting. But if you're running a consumer app, and most of your customers are just regular people, then they may not want to know, they may not understand, so you may need to simplify some of the explanations. And this really depends on your audience. But the goal that we try and get to is that we get thanked for our instant postmortems. We try as hard as we can to avoid them through good systems design, but we don't spend $1 billion a quarter on our infrastructure, and so these things are going to happen. And so the goal is to make sure the process works and you solve that for future problems. Thank you very much.
We've got time for a few questions. So, yeah.
So the question was, do we use any specific tool to simulate war games? We don't. We have a copy of our production environment, and we just cause problems with it and make people respond to that. We use HipChat just so that everyone's in a room and simulating it as much as possible. But it can just be like the Chaos Monkey, Chaos Gorilla style things, just pulling cables out if you have the cables, dropping a database, all that kind of stuff. Yep.
How applicable do you find your checklist mentality to be within the context of problems that you haven't seen before?
So the question was, how applicable is the checklist when it's a novel problem that you haven't seen before? I think the checklist works up to a certain degree. It's checking off the most likely issues. It's also the initial response and going through making sure you rule out kind of that low-hanging fruit. But once you get to something that has never happened before, then you just have to use your expertise and your knowledge and the rest of the team. I know that was a case in the Qantas issue where the engine exploded on the A380, and they had so many system failures that they couldn't go through all the checklists in time, and so they had to prioritize the different systems. And that's where you rely on the expertise of the pilots in this case, but the expertise of your staff to know enough about the system that they can make an educated guess and then investigate it. Yeah.
Have you thought about having an automated, automated pre-primary? Because it sounds like your checklists actually cover quite a lot. You could probably, especially that one where I was saying, can you SSH into the box? Mm-hmm. If not, do this. If not, do that. It seems like a kind of chatbot possibility.
So the question was about automation and how much can you automate as an initial, this is what's happening dashboard. I think that's a good approach. We want to automate as much as possible, and the idea is not to page someone. If you've got a checklist where you're just executing a couple of commands, then really the alert should just trigger a webhook to execute that script, and then you fix the root cause. So you don't want your humans to become just bots executing lists of commands. Initially, when you deploy a new system, you may not know what the failures are likely to be. That example was a simple one of just SSH in, can you access the server, that kind of stuff. And these are fairly rudimentary and basic checks. The idea is to automate as much as possible so that your team is involved in actual real debugging. Yep.
It's a quick one. How do you monitor your platform?
So the question is, how will we monitor our monitoring?
That's a real question.
Yeah.
What you choose.
We use ourselves. So we have a separate installation in a completely isolated environment that monitors ourselves. And so when we're using our own product. But we also use New Relic, Pingdom, and server density. Yeah.
Thank you very much again.
Thank you, everybody.